Hello everybody, this is Willie, and this is part of Nancy's Notes in Ophthalmologic Review. We're working on Section 12, Basic and Clinical Sciences. This is Retina and the Vitreous. So the very beginning of this is pretty straightforward, it's just about the anatomy, and the first section is on the vitreous itself. So the vitreous occupies how much volume of the eye? 80% of the eye is the vitreous. It's a clear matrix composed of collagen, hyaluronic acid, and water. Three things. The body of the vitreous is composed of two parts. The central or core vitreous and the cortical vitreous, the outer portion. The anterior bounding surface of the vitreous body is the anterior hyaloid membrane, a condensation of protein fiber that has a retrolental indentation called the patellar fossa. In the vitreous base, the collagen fibers are especially dense. They implant into an area that extends 2 millimeters anterior and 3 millimeters posterior to the ora serrata. These fibers are very difficult to disinsert during surgery. The fibers extend radially in towards the vitreous gel for several millimeters. The vitreous gel contains collagen fibers that arch posteriorly. Okay, so between the collagen fibers are hyaluronate molecules, which bind water molecules. These hyaluronate molecules, with their associated water molecules, act as filler and separators between the adjacent collagen fibers. The collagen fibers in the cortical vitreous are much more densely packed in a felt-like network. These fibers course in a direction roughly parallel to the inner surface of the retina. Although the vitreous is most firmly attached to the vitreous base, remember this, it is also firmly attached to retinal vessels, the optic nerve, and the macula. Okay, so the vitreous is attached both to the vitreous base, the vessels of the retina, the optic nerve, and the macula. The attachment of the vitreous to the macula is arranged in three circumferential zones, centered on the foveal. Remember, the specific attachment configuration influences the morphology of tractional maculopathies. Okay, so now we're going to talk about liquefaction of the vitreous, and that starts really early, around age 2. And it starts in a zone above the posterior pole and produces a space known as the premacular bursa, or the precortical vitreous pocket, and I'll show you a picture of that. The anatomy of the vitreous is difficult to delineate in vivo, but the vitreous appears to contain interconnected smaller bursa as well. Okay, so what happens over time to the vitreous cavity? Well, it develops larger and more numerous pockets of liquefaction. Okay, not bad. What leads to the destabilization of the vitreous gel? Enzymatic and non-enzymatic cross-linking of collagen fibers, free radical damage, big surprise, and decrease in the network density of the collagen fibers. Okay, so eventually the vitreous gel starts to shrink, putting various portions of the retina under what kind of stress? Oh, easy, tractional stress. Focal traction on the retina may produce retinal tears or holes. I could have said that. The vitreous may also place traction over a somewhat larger area of the retina. Because the resultant tensile force is spread over this larger area, it's kind of below the threshold to cause a tear. But instead, this force may distort the retina or cause tractional elevation of the retina. One example of this process is the vitreomacular traction syndrome. Vitreomacular traction syndrome. It's a condition where the patient develops blurring vision and distortion of central vision because of the traction of the macula by the vitreous. Yeah, but more focal traction of the fovea may produce foveal cavitation and macular holes. The force vector on the macula from the vitreous traction are probably modified by the presence of bursa. The posterior vitreous starts to detach from the retina in discrete zones, but later may detach from wide areas of the posterior pole. Yeah, and do you know what that produces? It produces vitreous detachment, which happens to almost everyone who lives long enough.